Chers membres, chers donateurs, vous allez découvrir ci-après le premier podcast de notre fondation. C'est un podcast qui est mis en place à l'occasion de la rencontre avec Alberto Orecchio, qui est professeur en médecine génétique à l'hôpital de Naples. Il est également membre du Téléthon italien, TIGEM. C'est un programme de thérapie moléculaire qui développe depuis de longues années. Vous allez entendre Alberto, un programme pour tenter de mettre au point un médicament pour soigner la maladie de Stargardt. May I ask you a few questions about your research, Alberto?
Okay.
When did you start working on Stargardt disease?
I started around 2008, 2007, 2008. I got interested in delivering large genes to the retina. I think ABCA4 was the first large gene that I tried to package into AAV particles.
I understand. What's the main problem with Stargardt disease? We know that it is a quite frequent disease, having quite a lot of research teams working on it. But when we work with gene therapy, it looks like maybe the size of the gene is very important, so it is much more difficult to bring it to the cells.
That's right. That's right. So that's what I mentioned. So my interest was mainly because I wanted to overcome this challenge of delivering large genes to the retina with AAV vectors. Because at the time, it was already quite evident that other viral vectors, different from AAV, like lentiviral vectors or adenoviral vectors, that have larger cargo capacity than AAV, they do not transduce the retina efficiently. So it was, in particular, the photoreceptors. So it was quite mandatory to do it with AAV, but AAV could only carry 5 kb, and the coding sequence of ABCA4 is larger. It's a little bit below 7 kb. So it becomes an important be able still to use AAV in the retina, but yet to carry ABCA4. And so we initially started to force this large gene into AAV capsids, and to some extent it works, because if you do these so-called oversized AAV vectors, you are able actually to induce ABCA4 expression in the retina. But the problem is that the vectors this oversized vector contain truncated genomes. So it's a material that it's difficult to bring then into the clinic because they are highly heterogeneous. So from a regulatory point of view, they are not ideal as a drug product. And so our initial efforts were in that direction. So the few initial years were spent on this part on oversized AAV vectors. And then when we realized that the system would not be applicable to the clinic, then we decided to use a different approach, which is to take the large gene divided into two and deliver it via two AAV vectors, so that the product is basically done of a mixture of two regular size AAV vector, each carrying one half of the large ABCA4 gene.
And then when it arrives to the target, it is recombining.
That's right. So when both the vectors infect photoreceptors in the retina of mice, or even of larger animals like pigs, they undergo a DNA recombination, and so the whole coding sequence is reconstituted. It was our second generation platform for ABCA4.
I see. It's an amazing work you did for all these years, Alberto. Can you explain us a bit? Sorry?
No, I just want to finish that the final product for EPC4 is not this one. It's based on two AV vectors, but the mechanism of reconstitution is a recombination between proteins. It's called the protein transplicing. It's a third platform that we have developed that uses a mechanism called protein transplicing, where each vector basically encodes half of the EPC4 protein. And then these half proteins undergo a protein recombination. So it's not a DNA recombination, it's that the two half proteins, they get fused together inside the target cells, and they basically regenerate the full-length EPC4 protein. And the reason we are using this system is because this system is more efficient than the DNA recombination, so the second generation platform that I described before.
Okay, so that's why it takes so long time to find the precise solution. And do you believe you are far from a clinical trial now, or do you expect it in the coming years?
I expect it in the coming years. So I think we have the final product to be developed. I don't think we're gonna continue to optimize, but I think we are at a level of efficiency that would be clinically relevant. At least this is what the animal model is telling us. And so what we are doing now, and this is done through private collaboration with a company, we are trying to raise the money to support the development of a phase 1/2 clinical trial.
That's wonderful. And on which animal were you proving the efficiency of your product?
So we have been using the mouse knockout for EPC4, so the mouse model of Stargardt on mouse data.
Okay, thank you. All this information is very interesting for our members, Alberto. Can you explain roughly what is your environment? I understood TiGEM was at the initiative of this project, possibly since 2006 or 2008 when you started. And you were mentioning that now you are expecting a collaboration with a private company to raise more money to go to clinic, which is apparently the case of most of the projects we are discovering on clinical trial. What is your situation on that matter?
Like a year ago, basically the Fondazione Teleton, which is also the owner of the intellectual property around these platforms, has created, and myself as a scientific founder, we founded a company that is called Avantgarde Bio, and this company is basically, the seed funding was provided by Sofinova, the French investors, and basically, so this project has transitioned from basically TiGEM, from the academic environment of TiGEM into the company for this further development. So basically CNC manufacturing, the IND enabling studies in a relevant species, which is probably going to be non-human primates. This will be carried on directly by the company through third parties, of course. Clinical trial should be carried out in Naples with Francesca Simonelli, because she has, Stargardt is probably one of the rare retinal diseases for which she has most experience. She follows up 500 patients with Stargardt disease. So
yes, so she
will be the clinical center for that, at least for this first phase 1/2 clinical trial.
We hope all of us that you will reach the clinical trial with success and as soon as possible, Alberto. And I thank you very much for answering to my questions. And all the members of the Fondation are behind you and hope you will have a lot of success. Thank you very much, Alberto. Have a nice time in Hindenburg, and I guess we will speak together very soon.